Okay, so this is the ACT test for the math section for December of 2017. So, all right, let's get this started. So a marble will be randomly selected from a bag of solid colored marbles. The probability of selecting a red marble is 519. So the probability of selecting a blue marble is 419. What is the probability of selecting a red or blue marble? So let's say there's 5 red marbles and 4 blue marbles. The probability of selecting either or red or blue marbles is going to be the sum of the two probabilities. So let me write this out. So this is for the red. You won't have time to do this on the actual test, but this is the process. So this is, adding fractions. If the denominator is the same, you can just add them right away. So the probability of selecting a red marble is five marbles out of the total. So there's 5 red marbles out of 19 marbles in the bag, and 4 blue marbles out of 19 in the bag. So the probability of picking either a red or blue marble is going to be the sum of these two probabilities. So it's going to be 9 out of 19. And that's one of our answers. Cool. So that's pretty much all you have to do for that one. Alright, let's scroll down. The graph below shows the number of students who were present on Thursday from each of the 5 groups in Miss Macon's class. What is the probability that a student selected at random from the class on Thursday is in group 4? Alright. Group 4. Okay. So, alright, so this is from Thursday. Okay, so this whole chart's Thursday, so we don't have to worry about what different days of the week there are for the data. Alright, so this is group number 4, and if we look right here and read the graph and go over, this is how many number of students that were in each group. So group 4 is 2. And if we count all of them, so this is 8. So 8, let's start from the left to right. So we're just finding how many, I can't write. So we're just finding how many people are in total. So 8, 12, plus 12, plus 6, plus 2, and plus, there's no one for 5, so let's just put 0. Alright, so that's 8 plus 12, 20, plus 6, 26, plus 2, 28, plus 0, still 28. Okay, so how many were in group 4 on Thursday? So there were 2 in group 4. Shit. In group 4 on Thursday. So how many were on? So let's reread the question. What is the probability that a student selected at random? So, just randomly sticking your hand, into the bag of marbles like the last one, kind of random. Selected at random from the class on Thursday is in group 4. So this is the chance that she picks anyone from any of these groups. So what is the chance that she picks someone from group 4 on Thursday? Well, it's how many people were in group 4 out of everybody. So everybody is this number. So it'll be 2 divided by 28. And that reduces to 1 over 14. That's our answer. Notice they kind of trick you right here. They put 1 over 28. It's kind of rude of them. Okay, so number 3. Consider the equation k equals 7 over 5. So I just always like to rewrite these. You may have time to do this or not. Let's see, for what value of j is the value of k equal to 40? So this one's kind of easy. So what value of j is the value of k equal 40? Well, just let k equal 40. And since k equals all this, we can just let this equal to 40. And now we just let, algebra take its way. So this is a symbol stating, next line of reasoning. So let's, minus through on each side. Equal, so 7 over 5j equals, we minus 54 from both sides. So 40 minus 54 is minus 14. Alright, so let's gonna run into down here. So it's times by 5 on both sides. So this is going to be 7j equals negative 14 times 5, which is negative 70. And now we divide through by 7. So j equals negative 10. And that's what value of j has to equal, so that equals 40. So if we plug j back up in here, which we don't have to, but just show that this works. 7 over 5, plug in negative 10 for j. You absolutely do not have to do this, but this is just for you. So, alright, so 7 times negative 10 divided by 5. Negative 70 divided by 5 plus 54 equals 40. Negative 70 divided by 5, that's kind of the reverse operation over here. So that's going to be negative 14 plus 54 equals 40. And negative 14 plus 54, that is 40. And that does equal 40. So negative 10 is our answer. Cool. What is the absolute value of 3 minus x when x is equal to 8? So absolute value means what is the number inside distance from 0. So the distance from 0 means, so let me just write it out. 3 minus x for x equals 8. So just plug in x, so 3 minus 8, absolute value, equals equals 3 minus 8 is negative 5. And the absolute value means how far from 0 that is. So since this is a negative number inside, you could think of it as a negative number inside an absolute value just goes away and it becomes 5. Or whatever number it is inside, in front of the negative value. But the absolute value means how far from 0 that this number is. And it's, this far. So if negative 5 is right here, then, negative 4, negative 3, negative 2, negative 1. So it's how far it is from 0. So it's 1, 2, 3, 4, 5. So that's what that means. And it's H, so 5. Okay. When Tyrese fell asleep one night, the temperature was 24 degrees Fahrenheit. When Tyrese woke up the next morning, the temperature was negative 16 degrees Fahrenheit. That sucks. Letting positive denote a rise in temperature, and negative denote a drop in temperature. What was the change in temperature from the time Tyrese fell asleep until the time he woke up? Okay. So, fell asleep one night. So, when he fell asleep, it was 24. So this is the temperature. So this is the initial temperature. So that's what that I equals. And negative 16. Here, let me write it like this. I'm making this a lot more than it is, but thinking more intuitively like this is a lot better. So this is the final temperature that he woke up to. So when you think of in terms of changes in something, you think of final, the final something minus the initial something. So in this case, it's, this is the final temperature when he woke up. This is the initial temperature when he started. So you do, final minus initial is equal to, the final is negative 16 degrees Fahrenheit minus the initial temperature, which is 24 degrees Fahrenheit. And negative 16 minus 24, that's negative 40 degrees Fahrenheit. That's our answer for A. Cool. So hopefully you won't need to write it out like that. You can just kind of notice that it went from 24 to 16. The minus sign, that's just a convention, stupid convention and stuff. That's why we don't really like to use Fahrenheit in the first place. In science, we use Celsius and Kelvin because there's no negative Kelvin at all, but there's negative Celsius, so Celsius is kind of dumb too. So okay, Ming purchased a car that had a purchase price of $5,400. Wow, which included all the other costs and tax. She paid a $1,000 as a down payment and got a loan for the rest of the purchase price. Ming paid off the loan by making 28 purchases of $200 each. The total of all her payments, including the down payment. The total of all her payments, including the down payment, was how much more than the car's purchase price? So the original purchase price was $5,400. That doesn't look like a 5, but okay. She put down, so this is how much it cost originally. This is the OG cost. And this is how much Ming put into the car. So she did, she paid $1,000. Alright, so let's see how much, let's add up how much other stuff she paid. So that was the down payment, and she got a loan for the rest of the purchase price. So Ming paid off the loan by making 28 payments of $200 each. So 28 times $200 each. The total of all her payments, including the down payment, was how much more than the car's price? So Ming spent $1,000 plus 28 times 200, that's $5,600. So $1,000, that's the down payment, plus how much she put in paying off her loan is 1,000 plus 5,600. So that's gonna be 6,600. So that's how much Ming spent. So So it's asking, how much more is this than the, the OG cost. So we take this number, $6,600. My writing's awful. Minus the OG cost is equal to $1,200. And that's G. Okay, cool. Shown below is a regular hexagon inscribed in a circle, whose radius is 4 inches. What is the perimeter in inches of the hexagon? Alrighty. So, what is it? So, you could say with this that this is a radius from the middle to a point in the hexagon. So you could draw a triangle side to another point, and since this point is a center to one of the sides as well, this is the same length, just like this one. And a triangle, a equilateral triangle, they all have the same sides. So this is so if this is 4, and if this is 4, then this side must be 4. And in a hexagon, all the sides are the same. Well, a equilateral hexagon. I'm assuming that there's other stupid hexagon shapes. But if that's 4, then this is 4, this is 4, this is 4, this is 4, and this is 4. So there's 6 sides to a hexagon. And if we know that one side of the hexagon is 4 inches, then we can write 6 times 4, 6 sides times 4 inches equals 24 inches. And that's the perimeter, so you add up each side, not how much space is inside that area. But okay, cool. So 24 inches. Alright. The floor plan for an L-shaped storage building is shown below. Shown below with the distances marked in feet. What is the floor area of the building in square feet? Walls in the building meet only at right angles. Alright. So for things like this, you really like to cut them up into, shapes that, we know. So we cut that off into a square, we can find out this side. So if we know that this whole side is 50, what are they calling it, square feet, right? And if this, much up here is 22, feet, then we can find out this side. So we can do 50 dash, this is just some convention, just kind of ignore it for now, unless they want you to convert something. So this is, 50 square feet minus 22 square feet is equal to 28 square feet. So that's what this side equals. Alright, so what are they asking for? The floor plan for an L-shaped building is shown below. What is the floor area of the building in square feet? Okay. So if this, so we can, let's separate this like we did earlier. So if this is 22 square feet, then this side must be 22 square feet. And that's the same up here. And so this 28 corresponds to this line. Yeah, okay. Now let's cut off this. So this 40 encompasses this whole entire thing. So that's 40. I have 22 of that. So if 40 is this whole side and 22 makes it this side, let's find out this side. So 40 minus 22 is 18 square feet. So that means this side is 18 too. Alright, so we found out, you know, this side and this side. Well, we already knew this side, but yeah. So 22 times 18. So that's this part. So this is the first area. So we know, so let's write a little equation. So area equals area of the L. Let's write a little subscript for the L shape is equal to the square, the area of the square. Let's write this. Area of the square plus the area of this rectangle. So this S is square, this R is rectangle, and this L is, you know, the L-shaped storage building. So it's nice to make little equations like this on the fly, and not just know equations, but it's nice to know equations too for specific problems. But for this, you want to kind of know intuitively, you know, what's going on, so you get it right and move on. So the area of S, the square, is this. So 22 times 18 square feet. I hate this convention. Is some number 18 times 20, 36, 360, 18 times 2 plus that's 36 plus 360, 396 square feet squared, but that's stupid. I hate using this convention. I don't know, just put that. They just want a number. So for the rectangle, so let's write it up here. So this side's 22 square feet, and this bottom is 50 square feet. So 22 times 50 square feet. You don't have to put parentheses around this one. I know I did down here, but I just like parentheses. So 22 times 50 is 50 times 20, 1000. 50 times 2, 100. So 100 plus 1000, 1100 square feet. I guess it should be square feet, since, you know, square feet times another square feet should give you, you know, feet to the 4th power, but oh well. Alright, so now we got this answer. So we have area of L equals the area of the square is 396 plus the area of the rectangle is 1100. That's 1496. Cool. Yeah, no, this one you should be able to do really fast. You just have to train yourself just to, you know. So the main point of all this is so that you can see some odd shape, cut it up into shapes that you know, and use some kind of geometry or some reasoning to, you know, find out, you know, this side and this side, and then, you know, you just go from there and kind of, you know, do this process really fast. So, okay. Spending a lot of time for a few problems, easy problems. So a quadrilateral ABCD with vertices -2. So let's plot these. So A is -2, 0. So let's say that's this one. A. B is 0, 4, so 1, 2, 3, 4. C is 5, 5. Alright, so 3, 4, 5. 1, 2, 3, 4, 5. D is 8, 2. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. That's D. We graphed in standard X and Y. Okay. Which of the following is a type of quadrilateral described by these vertices? So a quadrilateral is like a rectangle, except, or a square, except that all of its sides aren't the same. So if we did some distance, formulas, from here to here, we would find that this distance is not the same up here, most likely not. So all these distances are not the same. So a square has sides that are the same, so that won't be it. A rectangle has two sides that are the same, so that won't be it. A trapezoid has only one pair of sides that are the same, so that won't be it. A parallelogram has two sides that aren't the same, but they're kind of slanted. At least I think so. Let me pull up something. Okay. So this is the shape that we got, alright? So a square has all the sides the same. A rectangle has two pairs of sides that are the same. A kite it's not really a defined shape. A parallelogram has kind of two sides that are the same. So this one, a trapezoid is when one, part of it appears different from the bottom. When this part is shorter than this longer part. So in this case it'll be a trapezoid, which I don't really like. But okay. That's a trapezoid, if you believe it, since this side is shorter than this side. Alright. Given that f of x, 3x plus 7, and g of x, value of f of g of 4. So, okay. So what this means is that when they say f of g of 4, that means whatever function is inside of this, so of f of x, you plug in the x. So if f of x is if f of x is 3x plus 7, then f of g of x is equal to 3 times g of x, which is x squared plus 2, divide by 2, plus 7. So that's what that is. And if we put a value for g, so f of g of 4 is equal to f of x, that function within that function. So if we put 4 into x squared, so 4 squared is 16. That's wrong. I put something I didn't want to. So 4 squared is 16 divided by 2. So this is 16 divided by 2, which is 8. 3 times 8 is 24. 24 plus 7 is 31. So do this on your calculator. So, when you see this, just, write out the function probably on paper first. And then, so when it says g of x into f of x, just plug whatever function they give you for g of x into x. So, okay. And when they put, 4 for the function of g of x, just plug in 4 for that x in the g of x equation. And that goes into your x for f of x, which outputs this number. Okay. At her hot dog stand, Julie sells hot dogs for $2 each. Purchasing hot dogs and other supplies costs $200 per month. The solution of which of the following inequalities models the number of hot dogs H. Julie can sell per month and make a profit? Alrighty. So if she sells them for $2 each, so that's $2, per hot dog. So if she makes $2 a hot dog, then however many hot dogs she makes, it's going to be times $2. So however many hot dogs she sells times $2 is how much she's making for all the hot dogs. And the other supplies costs $200 a month. So, like mustard, bread, and all that all adds up to $200. So, so a profit is how much you're putting into it, is how much you're getting out of a business. So like pretty much total amount of money minus how much money you put into the business. So all the money she'll be making from this business is from the hot dogs. And if she makes $2 per hot dogs, this is where all her income is going to be coming from. And she has to, put some supplies in. Then you have to minus, however much you put into that from, the total amount of, income that you made. So, so that's going to equal to 0. Well, no, it's not going to equal to 0. So, you want this to be greater than 0, hopefully. So, so she has to, sell at least, so if we do some, math, 2h, so you plus 200 to each side. H is greater than 200 divided by 2, which is 100. So she has to sell more than 100 hot dogs per month if she wants to make any profit. Okay, so if she sold 101 hot dogs, then this would hold, and any other hot dogs beyond that. So yeah, so this is the equation that you want. So $2 per hot dog minus $200 in supplies is greater than 0, because you don't want to do all this and make no money in a successful business. So okay, so $2 times hot dog minus supplies, that's not the one we want, this is the one we want. In the standard x and y coordinate plane, what is the slope of the line 3x plus 8y equals 5? So this is a standard, so this is for a, so the y equals mx plus b. I don't really like how they use why they use them, but okay. So you want to get this in that form. So this is a really pretty much a linear, equation. So okay, let's, do some math. So let's write the equation. So it's, minus 3x from each side. So then we have 8y equals 5 minus 3x divide by 8 through on each side. So y equals 5 minus 3x divided by 8. And the slope is however much is making the x rise. So the slope is whatever number is outside of this x. But here's where they trick you. They're trying to make you not account for this. So split this thing up to make it easier to see. So this is really 5/8 minus 3x divided by 8. This is the same thing as that. Okay? So whatever number is outside of x, so the number outside of x is a minus 3 divided by 8. That's our answer. That's how much x is changing for every increase. Alright, so which of the following xy pairs is the solution to the systems of equations? Alrighty. So this is kind of, you can do this in your calculator if I show you, but you don't really need to. For bigger equations like this, you would do this on a computer. So okay, so these are two coupled linear equations. So you can change this up here to make a variable down here cancel out. So algebra, right? So you times each side by 2. Let's do it like this. So it's times this side up here by 2 and this side up here by 2. Math is math. Math holds. So this equals to 2x plus 2y equals to 4. And down here we change nothing. And if we add these two now, then you can see that 2x plus minus 2x, that cancels out. So if we add these two now, so just kind of add down like this. It's pretty nice convention. So 2x plus negative 2x is 0. 2y plus y, that's going to be 3y. 4 plus 16, that's 20. And we can divide by 3 on each side. So y equals 20 over 3. Now if we plug that back into one of these equations, we get, let's see. Oh no, I did this wrong. Oops. My bad. I didn't do math right. This is 4. Because, 2 times x times 2y, that's 4. So, again, would you add these two? 0. 4y plus y plus 5y equals to 4 plus 16, 20. Y equals 4. Because you divide by 5 on both sides. So if you plug this back into one of these equations, so let's do it for this one. So minus 2x plus y equals to 4 equals 16. Minus 4 on both sides. You have 2x equals to 12 now. And x equals 12 divided by negative 2 is negative 6. So we have our x, which is negative 6. And our y, which is 4. So it's A. Cool. So on a map, 1/4 inch represents 16 actual miles. So two towns that are 2 3/4 inches apart on this map are how many actual miles apart? So how you do this, you take, the total number of inches on the map, or well, that they give you, and you divide it by this conversion factor. So 1/4 is equal to 16 miles. So we want to find out how many 1/4 are in this 2 and 3/4 inches. So let's do that. Divided by 1/4. So you could do this on your calculator, but you know that 1/4 goes into 2 8 times, and there's 3 1/4 right here. So this should be 11. Alright. Math adds up. So that's how many 1/4 are in this number. Okay. So now we take this number and times it by how many miles is represented by 1/4. So 11 times 16 miles is going to be 16 times 11, which is 176, and that's our answer. Cool. Let's see if I'm still recording. I am. Which of the following matrices is equal to this? Alrighty. So with matrices, they're just like an array of numbers. So they're just a listing of numbers. So they work pretty much the same as anything else in math. So 4 times this matrix of -1, 2, 0, -4 is equal to, so 4 times -1 is -4, 4 times 2 is 8, 4 times 0 is 0, 4 times -4 is -16. So this matches down here, and that's our answer. That's pretty easy. Just take this number and multiply everything inside by it. Alrighty. What is the value of tan A in the right triangle below? So tan of A. Alrighty. So since this is of A, let's rewrite this as there we go. That's rewritten. So tan of A. So tan of A is sine over cosine, and also opposite over adjacent. So tangent of A is 15 divided by 8, and that's our answer. Okay. So Tina runs at a rate of 8 miles per hour. At that rate, how many miles will she run in 12 minutes? Alrighty. So let's teach you about dimensional analysis. So 8 miles per hour. Per hour. So 1 hour is equal to 60 minutes. So let's rewrite this as 8 miles per 60 minutes. How many miles will she run in 12 minutes? Okay. So if we take this number, so we do 8 divided by 60, which is I think it's 7.5. Yeah, 7.5 miles per minute. Since there's only 1 minute. So, 7.5 miles every 1 minute that she run. That's not right. Oops. That's 1 mile every 7.5 minutes. Alright, that's correct now. So, if she can run 1 mile every 7.5 minutes, then we can set this equal to, you know, like a math equation. So this is our unknown. so we want to know how many miles. So this is x miles divided by, you know, 12 minutes. Why am I writing the full word if I just write min? Alright, so she runs this many miles in 12 minutes. And if we know that she can run 1 mile in 7.5 minutes, then we can just, you know, figure out this. So let's do, you know, this, the bottom times the top, and this bottom times up here. So 7.5 minutes times x miles is equal to 12 minute 1 mile. So let's divide 7.5 minutes on each side. So we have x miles is equal to 12 minute 1 mile divided by 7.5 minute. So we can see that these minutes cancel out. 12 divided by 7.5 is some number. Let's use your calculator for this one. It's 1.6. So x miles is equal to 1.6 miles. So, you know, miles cancels out, and x equals 1.6. So 1.6 is D, since 1, you know, 3/5 is 1.6. Alright, cool. Alrighty. A function f of x is defined as f of x equals to negative 6x squared. What is f of negative 3? So all you do is, you know, type this on your calculator. Equals negative 6 negative 3 squared. So negative 3 squared is 9, and 9 times negative 6 is 56. Oop, no, it's not. It's negative 54. Can't do math today. Since 9 times 6 is 54. And this negative is still lingering out here. Since, you know, PEMDAS, you know, you take your parentheses and then you know, exponent power them. So negative 3 squared, 9 times, then you do multiplication, 9 times negative 6, and you got negative 54. Cool. In the figure below, A is on the line BE, and C is on BD. Alright, that checks out. What is the measure of angle ABC? So this is the angle that they want. Alrighty. So we can do some geometry. So E will be 132. This will be 132. This is on a straight line, and this will be 132. Okay, so 132. so we know 132, and that intersects that angle, so that would be 132. This is complementary, so that's 132. That intersects, that's 132. And on this line, you know, this angle plus, you know, this angle is going to equal to 180. So that angle is equal to 48, because, you know, 180 minus 132 is equal to this angle. And in a right triangle is 180. You know that this is 90 degrees. So 180 minus 90 minus that angle that we found, 48. And that's going to give you 42 degrees. Alright. Cool. Let's move on. Marcos programs his calculator to evaluate a linear function, but he doesn't say what the function is. When 5 is entered, the calculator displays the value 2. When 15 is entered, the calculator displays the number, the value 6. Which of the following expressions explains what the calculator will display any number n is entered? So let's see. When 5 is entered, so let's say f of 5 is equal to 2. So, you know, he's entering 5 into his calculator, that's putting it into some function, and it's outputting 2. When 15 is entered, the display is 6. So let's do f of 15 is equal to 6. Alrighty. Alrighty. So we can do 15, f of 15 minus f of 5 is equal to 4. Where am I going with this? Let me erase all this. So the first one gives a a value of 2. So let's write the value that gives out over the input, 5. And this is And if you do the same for this side, it reduces to 2 over 5. So this is the relation. So if you so all right. So this is the relation. So that when you input, 5, you get 2 out. And if you do 2 over 5 times 3, you get, 15. That's 2 times 15, 30 divided by 5 is 6. So if you do this relation, so 2 over 5 times n, you'll get, you'll get that input back. So the answer is F. Cool. On Friday, the temperature at 8 a.m. was 49 degrees Fahrenheit, and it rose at a constant rate of 1/2 Fahrenheit per hour until noon. A cold front passed through at noon, and the temperature then fell at a constant rate of 1 degree Fahrenheit per hour. The temperature first fell below 49 degrees between... Alrighty. So from 8 a.m., till noon. So noon is, 12 o'clock p.m. So if it was at an initial temperature of 49 degrees Fahrenheit, and it went up at a rate of, 1/2 degrees, per hour. So 4 hours passed, so 4 times 1/2, that'll be 2 degrees change. So at 12 o'clock p.m. it was 51 degrees Fahrenheit. Since, it went from 8 a.m. to 12, 12 minus 8 is 4. 4 hours between these two. And if it went up a rate at 1/2 Fahrenheit per hour until noon, so you times that by the difference. So 1/2 Fahrenheit per hour times 4 hours, that'll give you a increase of 2 Fahrenheits. So you add that to 49 and you get 51 Fahrenheit. Then a cold front passed through at noon, and the temperature then fell at a constant rate of 1 Fahrenheit per hour. So cold front happened at 12 p.m. Then it went down -1 degrees Fahrenheit per hour. So for this to go from 51 degrees Fahrenheit to below 49 degrees Fahrenheit, it would have to be, at least 3 hours, or greater than 3 hours. So that'll be 3 hours plus 12 p.m. So right around 3 p.m. it started to go down. So if we come right here, then 3 p.m. to 4 p.m. is when it started to go below 49 degrees Fahrenheit. So these are answer. Nice. 22. Letter grades in Hugo's math class are based on the percent of total possible points on 4 unit exams. Each is worth 100 points, and the final exam is worth 200 points, and are assigned accordingly to the chart below. The number of points scored on the unit exams this term were 82, 88, 91, and 83. When course grades were posted, Hugo's course grade was listed as a B. Which of the following could not have been the number of points he scored on the final exam? So, if there's 4 unit exams, each worth 100 points. So that's, 4 unit exams, 100 points. Worth of 100 points. So that's 400 points he got for the 400 points total that you can get from the unit exams, and the final exam is worth 200 points. So the maximum total of points you can get is 1600 points. And if he got, 82 plus 88 plus 91 plus 83 points on the unit exams. So this is 82 plus 88 plus 91 plus 83. That's 344 out of 400 points that he got. So to get a B, you need to get at least 80%. So 80% of 600 is 480 divided by 600. So if he got 344 points on the unit exams, then he needs to get higher than what this value is. So 80% of 600 points is 480. So 480 is the total amount of points. And if Hugo has 344 plus X over 600 possible points. So X is what he made on the final exam. So which one of these is not the number of points that he scored? Well, let's see. Okay, so it was listed as a B. What? What the hell is this? Okay. Oh, okay. So he made a B. So he has at least that. Alright. So okay, so when he took the so if he went over this, alright, so 90% of the grade, so do 0.9, 90% of 600 is, so 90% of 600 is 540. If he made over this, then that could not have been his grade. So 540 over 600 minus 344. Over 600. Let's go to 196 over 600. So 196 is a grade that he cannot have made to get an A. because he made it B. So the answer is 196. Okay. So yeah, no, that one I was being stupid on. Haley is bowling a series of 3 games. She has bowled 2 of 3 games with scores of 148, 176. The figure below is a top view of the bowling lane. The dimensions for the bowling lane are given in the figure. The pin deck is the rectangular area within the bowling lane where the 10 bowling pins are set up. Alright. So, figure's not drawn the scale. The diameter of each pin at the base is 2.25 inches. When all the pins are set up, which of the following values is closest to the area? Alrighty. Let's see. What is it asking? Which of the following values is closest to the area in... Okay. Bases of the pins. The pin deck is the rectangular area within the bowling lane where the 10 bowling pins are set up. The diameter of each pin at its base is 2.5 inches. When all the pins are set up, values is closest to the area. Okay. So this is 5 feet, and this is 3.5 feet. So this little box is 5 feet, and this side is 3.5 feet. So this is gonna be 5 times 3, 15. 5 times 0.5, 2.5, so this is going to be 17.5 feet squared, technically. So, they want the area of the inside, so if the diameter of each pin at its base is 2.25, when all the pins are set up, which of the following values is closest to the area in square inches that is covered by the base of the pins? That doesn't make a lot of sense. Well, so, okay, there's 10 of them. So that'll be, 22.5 feet squared. So we do 17.5 feet squared plus 22.5 feet squared. And that's, 39.75. No, that's 40. 40 feet squared. So, that's a dumb question. I don't like that. What is the ratio of the total area of the bowling lane to the area of the pin deck? Alright, so we found the area of the pin deck. So the entire bowling lane is 65 feet times 3.5 feet. And you could do, some math like this. 5 times 3.5 feet. These cancel out. 5 over 65 is 1 over 13. And that's G. So that's a kind of fast way to go about it, so you don't have to waste time picking up your calculator and typing that in, even though that's a fast process, but every little second counts. What score will Haley Hale need to earn in her third game to have an average score of 172 for the 3 games? So 172, that's an average for the 3 games. So, you know, times 3 is 100 and 516. Yeah. Let's double check that. Yep, 516. So, if she scored 148 and 176, let's go. So, what number does this have to be 516? So, you know, 176 plus 148. So, that's going to be 324. 516 minus 324. That's 192. D. Cool. Cool. Alright. The area of a rectangle is 300 square meters. And its length is 3 times than its width. How many meters wide is the rectangle? Alright. So the area is 300, so let's just 300, and this is 3 times its length. Alright, hold on. Area is equal to 300, and if it's base times length, so this must be, it's 3 times its width. So this is 3 length times width. Alrighty. So, you know, this one you could square meters, meters wide. So for this one you could, you know, really just, you know, plug in, you know, these values and kind of see. It's 3 times its width. So the length. Oh, I'm stupid. So the length is 3 times width. It's 10. It's 10. I don't know why I'm being dumb with this. Hold on. So the length. Here you go. I got it. Alright, so the area is 300. And if area is equal to length times width, and if the length is equal to 3 times the width, then area is equal to 3 width times width equals to 3 width squared. And if the area is equal to 300, then do some, you know, math. It's width squared equals to 300 divided by 3, which is 100, and square root of width. So width squared is 100, and so width must be 10. How many meters wide is the rectangle? It's 10. There we go. There we go. A parallelogram has a perimeter of 96 inches and 1 of its size. Alright, so draw a picture. So its perimeter is 96 inches. So let's say this one's 16 inches. It can be determined if it can be determined, what are the lengths and inches of the other three sides? Well, we know two sides are the same, so let's let that be 16. 96 minus 32 equals 64. Divide by 2, 32. So 16, 32, 32. Yep. So, yeah, a parallelogram is, you know, it has two pairs of the same side. So, you know, one side's 32, this side's 32, then 16, 16. It'll have two pairs of the same sides. So, yeah, if you know one side, then you can find the rest. Alright? So, Elmhurst Street is a two-way street in each direction. And it has a 12-foot wide lane for car traffic, one 6-foot wide bike lane, and one 8-foot wide parking lane. How many feet wide is Elm Street? Well, let's just add them up. So 12-foot wide lane for car traffic, 12 foot, one side, one 6-foot wide bike lane, 6 feet, not drawn to scale, and a 8-foot wide parking lane, 8. So 8 plus 12 plus 6, 26. Alrighty. At Central High School, wow, Central, 4 out of 10 students ride the bus to and from school, and 3 out of every 8 who ride the bus are freshmen. If there are 2,500 students at Central, how many of the students are freshmen who ride the bus? Alrighty, I like this one. So 4 out of 10 ride the bus. So 4 out of 10 times, you know, the total is 2,500. Which is, you know, 4 times 2,500, that's 10,000, divided by 10, that's 1,000. Who ride the bus? Alright, so that's how many people ride the bus. Now, if 3 out of 8 who ride the bus are freshmen, so 3,000 divided by 8, that's, let's say it's under 400. Alright, well, the options are only one. So this will be 375. Alright, so 29 is A. Cool. That's how you deal with these probability-like questions. If 90 degrees is less than theta, and 180 degrees is greater than theta, and sine of theta is equal to 20 over 29, then what's cosine of theta? So for this one, alrighty, use that inverse sine function. Make sure your calculator is in degrees. So you get, you know, some number 43.660. So then you do the cosine of this, and you get, you know, 0.724. So figure out what that is. That's not right. Did I even have mine in degrees? Sine of theta. Oh. Hold on. Sine of 20 divided by 29. Alright, so that's theta. Then cosine of theta. I'm gonna equal that. Oh, I see. So for this one, you kind of need to, know some trig. So cosine of theta is equal to cosine. Hold on, let me rewrite this. I made this confusing for myself. So cosine of theta. So cosine of this 43.60 is roughly 0.72. Now, as that stands, for the cosine function, so cosine of theta, it is equal to cosine of negative theta. So this is just a property of cosine functions. They're called even functions, and when you take a negative input within an even function, it's gonna spit out a positive input. So just like x squared, if you put a negative number into that, that's gonna come out to be positive. Okay. So that's an example of an even function. So the answer you get is like 0.724 or something, and you're gonna come over here and panic. You're gonna be like, oh no, the positive ones aren't 0.724. Then I made a mistake. But no, you didn't make a mistake. Just look at the fractions, and it's negative 21 over 29. So when you put this into your function, cosine, you're gonna get this out. All right. So when you take cosine of negative 21 over 29, you're gonna get 0.724. Okay. So the answer is H. So given f of x equals 2 over x plus 1, what is / are the real values of t for which f of t equals t? Alright, so if f of t is equal to t, so that means if you put in 2 right here, that's going to give you 2. So let's look over here at the choices. If you plug in -1 down here, that's going to give you infinity, because 2 over 0, you can't divide by 0. It gives you pretty much infinity. So mark off all the ones with -1. Alrighty. 2, when you put in 2 down here, you get 2 over 3. So that can't be right. So mark out the ones with 2. And if you put in 1 down here, or 1 in here, you get 2 over 1 plus 1, which is 2, which is true. And if you put in -2 down here, you get -2 plus 1, which is -1, but it's 2 over -1, so you get -2 back. So the answer is C. Nice. In the figure below, a highway rest area at D and radar stations plotted on the level east line. A is 9,000 feet due west of D, and airplane at C is shown directly above the rest area, flying due west at a constant speed of 300 feet per second. In a constant altitude of 12,000 feet, the airplane is located at a straight line distance of 15,000 feet from the radar section at A. Alright, what's it asking? Which of the following values is closest to the distance in feet between the 2 radar stations? Alrighty. So, what's the radar stations? And the radar stations, A and B. Alright. So that's the airplane. Radar stations. So they're asking for this distance. So, right triangles. Alrighty. if this is a right angle, then this is also a right angle. And we know this number, so 13,000, and this number, and we know this number, 12,000, right angle, what is this number? So, you know, a squared, b squared equals c squared, so do c squared, you know, minus, a squared if you want that to be a squared. That's usually a squared, so do 13,000 squared minus 12,000 squared, and it's going to give you x. So usually, 13 squared, so you don't even have to do 13,000, you can do 13 squared. 13 squared is 169 minus 12 squared, 144, that's 25, which is x equals 5, but this is in thousands, so x equals 5,000. And that's correct. Wait, hold on. Oops. Hold on. I fell victim. So that's the distance from here to here. They try to trick you. So this is 5,000. Alright, so they're asking for the distance between A and B. So you do 9,000 plus 5,000, which is 14,000. Okay, so moving on. Let A, comma C, comma and D lie in the standard x and y coordinate plane, such as A is at 0, 0, and D is at 9,000, 0. Which of the following equations represent the line along which the airplane is flying? Alrighty. Well, so A is at 0, 0. Alrighty. D is at 9,000, 0. Oh, well, I mean, 33. So if you match it up right here in the picture, it's flying at a height of, 12,000. So Y should just be C. Which of the following values is closest to the number of seconds it will take for the airplane to fly from C to the point directly above the radar station at A? So it's going to take 15,000 feet to get there, and it flies at 300 feet per second. It comes out to. So do 300 feet per second. So you take, so it's got to go from C to A, so you take 15,000 and divide it by 300 feet per second. This is going to equal to 50. 50, the feet cancel out, and seconds gets sent up here. So it's going to take 50 seconds. That's not. Alright, so if the airplane at C is, you know, at D, and it's got to go to A, then the distance from D to A is 9,000. So you do 9,000 feet divided by, it travels at 300 feet per second. So 9,000 divided by 300 is 30 seconds. Because the feet cancel out. And the answer is G. When considering the changing triangle formed by A and B, the moving airplane C, which the angles below increases in measure as the airplane flies due west beyond the point directly above A. Oh, okay. Let's see. Due west beyond the point. A, B, and C. Oh, well, I mean, C is going to stay the same because as it moves, this triangle is going to, move this way. It's a vector, actually. And so, A and B is going to change. So angle A, it'll be 1 and 2. Yeah. Hold on. When considering the changing triangle formed by A and B in the moving airplane C, which of the angles below increases in measure? Oh, okay, increases. So as it flies this way, it's asking which one of these angles increases. So as it moves this way, this angle right here, it's gonna, collapse. It's gonna, go down and decrease in value. But this one's just gonna get bigger. So yeah, it's gonna be A. Troy made a rectangular poster that is 4 feet long, 2 feet wide. The poster is too large to fit in the available display. So Troy's going to make a new poster that will have an area that is 50% of the original poster. Oh, well, let's go ahead and find that because I'm sure we'll need it. 2 feet wide times 4 feet long. 8 feet squared. So if he's going to do 50% of that, so his new poster is 50% times 8 feet squared, which is 4 feet squared. The length of Troy's new poster would be 3/4 the length of the original poster. Well, the length of the original poster was 4 feet long, so 3/4 times 4 feet is gonna be, 4's cancel out, 3 feet. How many feet wide will the new poster be? Well, let's do some math. So this is the area of the new poster. We have a length, so let's do 4 feet squared divided by 3 feet squared. Oh, no, that's not squared. So this is 4 feet squared divided by 3 feet. So this feet cancels out with the one on the top. So now you only have 1 feet. So you have 4/3 feet. And 4/3 feet is 1 1/3 feet. So it's 1 1/3. So 36 is G. What is the solution set of the equation? Alrighty. X plus 6 equals 2x plus 3 minus x. So let's, take x to each side. 2x plus 6 equals, let's multiply this out. 2x plus 2 times 3, 6. Oh, this is gonna. This is equal to each other. Yeah. This is gonna have no solution. Well, no solution. I mean, it has all the solutions. So you could fit 1 in here, 2, 3, 4, 5, 6, 7. So yeah. So you look if you let 1 in here, it's gonna equal to that. So whichever numbers that you put in here, that's a real number, it's gonna equal to that side because it's the same over here. So it's E. Alrighty. Steve plans to use 28 feet of fencing to enclose a region of his yard for a pen for his rabbit. What is the area in square feet of the largest rectangular region that Steve can enclose? 28 feet of fencing to enclose a region of his yard for a pen. In square feet. Alrighty. So what is the largest that he can make of this? So if he does 14 for each side, yeah. So you split that in half and multiply it by each side. Yeah. So this is the area in square feet. Actually, hold on. What is the area in square feet of the largest? No, wait, hold on. I overshot the gun on this one. So, if it's 28 feet around, so you split that in 4, so each side gets 7. And since it's, the area, you're trying to figure out what this is. You do, length times width. So 7 times 7 is 49. It's J. There are exactly 5 people in a bookstore at 12 p.m. Each person earns an annual income that is between $30,000 and $35,000. No one enters or leaves the bookstore. Okay, so let's look at this one. There are exactly 5 people in a bookstore at 12 p.m. Each person earns an annual income that is between $30,000 and $35,000. No one enters or leaves the bookstore until 12:15. When a professional athlete with an annual income of more than $1 million enters the bookstore and joins the other 5 people. The mean, median, range, and standard deviation of the annual incomes of the 5 people in the store at 12 p.m. are calculated and compared to the same 4 statistics of the annual income of the 6 people in the bookstore at 12:15 p.m. If it can be determined which of the 4 statistics changed the least. Well, the range, median, and mean and standard deviation of a set of data really helps explain how the data is confined. So let's say we have someone who makes 30,000 and someone who makes 31,000, someone who makes 32,000, someone who makes 33,000, someone who makes 34,000, whatever the comma. So this would be a mean, like a typical mean of 5 people. I just chose these numbers just because they're clean looking numbers that are from 30,000 to 35,000. And when this is add up, it comes out to be 160,000. When you take the mean of this set of data, you add all the numbers up and then you divide it by how many numbers there are. So there's 1, 2, 3, 4, 5 numbers. And your mean will be 32,000. So this is the mean. Now the median of this set would be the number that's in the middle of an odd set. If your median was in a data set that had 6 numbers, so let's say that this was a let's add another 33,000 in here. Your median will then be the average of the 2 middle numbers. So it would be 32,000 plus 33,000 divided by 2, which would be 32,500. So that's how median works in this. So this is the mean, and this is the median. Alright. So your range is pretty much the biggest number in your set of data minus the smallest number in your data. So in this case it would be 34,000 minus 30,000. So your range would be pretty much 4,000. So pretty much the range just tells you, how big your smallest number grows to your, or the difference between your biggest number to your smallest number. Now the standard deviation, that's based on this bell curve. This is more of a thing in statistics that you learn about. And it's divided up into these various sets. So this curve would be 34%, this would be 34%, and this would be like 16 something, and etc. And these different percentage values. So this will not really change the data all that much, but you'll learn how to use this more when you take statistics. But so this question's asking when someone who enters the data pool makes more than $1 million. So if someone walks in and makes this much money, then it's asking which one of these 4 things changes the most. So if someone walks in who makes $1 million, the mean's gonna come out to be all this stuff added together divided by 6 now, which will come out to be on your calculator to be let's see, it'll come out to be about 165 1,714 ish. It'll come out to be around that number. Now your median is the number in the middle of your set. So So since this number is not really gonna change the median, since the median's gonna be, you know, between these two numbers, your median's gonna actually become, you know, that 32,000 plus 33,000 divided by 2. So it'll be around roughly, or not roughly, equal to 32,500. So that's what your new median's gonna be. This is what your mean's gonna be now. And now your standard deviation won't really it'll change a lot, but not as much as what the next thing that we're going to talk about. Now the range is going to change a lot, because when you add this really giant number to a relatively small data set, then the range from 30,000 to a million is going to be the biggest difference. So 1 million minus 30,000 is going to be 970,000. So that's a lot different from 30,000 to 34,000. So that's the answer, A. Oh, well, it's saying what changes the least, actually, so it's going to be C, the median. Alright, so let's look at 40. Anna and Amy started a landscaping job together. When Anna stopped, she had completed 2/5 of the job. When Amy stopped, she completed 1/3 of the job. Then Ruben completed the rest of the job in 2 hours. Assume that Anna, Amy, and Ruben all worked at the same rate. Which of the following is closest to the number of hours it would have taken one of them to complete the entire job alone? So, alright, let's see. A landscaping job together. When Anna stopped, she had completed 2/5 of the job. So, let's just, add it up. So, let's see. Anna, this is how much Anna did. When Amy stopped, she completed 1/3 of the job. Then Ruben completed the rest of the job in 2 hours. Okay. He completed the rest of the job in 2 hours. Let's just say 2 hours for Ruben. It doesn't say how long that they worked for, so. Okay. 2/5 of the job when she stopped. Okay. Okay. So let's say that the job is pretty much out of 1. So let's make these fractions have the same denominator. So let's make 2/5 times 3 on the top and 3 on the bottom, and then let's make 1/3 times 5 divided by 5 on the bottom. So that's going to be 5/15, and this is going to be 6/15. So let's add these two fractions. So 6/15 plus 5/15 equals 11/15. So Ruben completed the rest of this in 2 hours. So Ruben did 4/5 in 2 hours. Okay. So let's say it takes them about, so, alright, so let's say 2 hours. So let's let me scroll down, have some more room. Let's say 415 equals, so 2 hours, let's say that takes him, so 2 hours is 60 minutes per each hour, so 120 minutes for 2 hours. So if we divide 120 minutes by 4 right here, then this will be 115 of work, and 0.5 hours. So 0.5 is 30 minutes. So let's times 0.15. So this is 1/15 of the work. So if we multiply both sides by 15, here, hold on, this. So 1/5 of the work equals 0.5 hours. So if we do, work equals 0.5 hours times 15, then it will be the work equals 7.5 hours total to complete roughly. So the answer is K. How do you do this? You first you write it out. Square root of B. A, B, -3. So let's rewrite this. Let's rewrite as 2 square root of B over A to the 4th power divided by A times B cubed. So that's it rewritten. We times this up here. We get 16B squared times B cubed. And that 4 is going to distribute to the bottom, which is going to be A to the 4th. And then that's going to be divided by another factor of A, so that's going to be A to the 5th. Alright, so this is going to equal 16B to the 5th over A to the 5th. Alright, let's see. So, to become a contestant on a quiz show, a person must correctly order 4 rock stars by age from youngest to oldest. The contestant knows which one is the oldest rock star, but randomly guesses at the order of the other 3 rock stars. What is the probability the contestants will get all 4 in the correct order? So, let's say that this is rock star 1, 2, 3, 4. Oh, actually, let's use letters. Let's say A, B, C, D. So, the contestant knows that this rock star is the oldest of this set. So, we can take this one out. Now, to guess what the correct order of this is by not knowing their ages, you have to do this kind of you could do it by brute force, or you can kind of think of it more elaborately. So there's 3 spots, and there's 3 spots, or let's say 3 people, only one one correct order. And there's two other spots that each Rockstar can occupy. So what I mean by this is that, so you can order them, you know, like this. You know, you got A, B, C. You have C, A, B. You have B, C, A. You have A, C, B. You have C, B, A. And you have BAC. So here, let me rewrite this. So I know that I have all my orders correct when I have this kind of pattern. So let me write ABC, and I'll write A again and swap these two, and I'll do B, and then just, you know, choose A or C, then write B again, then write C or A, then write C, then write, you know, B or A, and then write C again, and then swap these. So this is what I mean by, you know, two other spots that can occupy. So there's like 3 sets of these. There's the A set, you know, the B set, and the C set. So this makes for a total of 6 different, you know, probabilities. So if you get, you know, if you get another question like this, you can kind of use this formula. You figure out how, you know, how many objects there are, and then you find out how many ways that it can be ordered. So, you know, if this was 2 different ways ordered, then the answer will be different. And you see how many other spots that that they can occupy. So, you know, if this was 4 people, then this will be 3. So yeah, so, you know, only one of these is correct. So, you know, there's 6 of these. So if only one of them can be correct, then that means 1 out of 6 of these is correct. So the answer is 1 out of 6. Alright. So which of the following expressions is equivalent to this? Alright, this is just kind of some algebra. Divided by 2, 3, minus 1/4. So how you can go about this is that you can, you know, take it a step at a time. You can, you know, combine these fractions down here. So how you combine these fractions is that you multiply, you know, the numerator of this by this, the numerator of this by the denominator, and then you take the denominator of this one, multiply it by the numerator of this one, and then you multiply each denominator. So this equals, so we're not going to change this up here just yet. So 2 times 4 is 8, minus 3 minus 1, or yeah, 3 times 1, divided by 3 times 4. So this equals, so here we can do the top. So x times 2 is 2x. 3 times 1 is 3, divided by 3 times 2, which is 6, and divided by down here, so 8 minus 3 is 5, and divided by 12. So you can now do this one by multiplying each. So you can basically so basically when you have a situation like this where you have fractions dividing another fraction. When you have a fraction dividing another fraction, you can flip this. So this 2x plus 3 divided by 6 is now being multiplied by 12 fifth. Alright, so this just basically just flips. Okay? So now you can, take this 12 and times it by everything up top. So this becomes 24x plus 3 times 12, 36, divided by, so since this is a multiplication symbol now we can just multiply these freely. So this is 6 times 5, which is 30. So over here, we need to reduce this, so this can all be divided by, 6. So if we divide everything, or, reduce everything by 6, then this will equal 4x plus 6 divided by 5. So 4x plus 6 divided by 5. It's D. So for this one, a automobile license plate number is issued by a certain state, has 6 character positions. Each of the first 3 positions contains a single digit from 0 to 9. Each of the 3 positions contains one of 26 letters. So, alright, so this one's kind of easy. So, how many different such license plates can be made? So, you have 6 character positions. So, you have 6 possible positions. So, if the first 3 positions, so, these 3, contain a digit from 0 to 9. So 0 to 9, that's 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 different numbers. So that's the same for each of these 3. So each of these could be 3 or 4. Like this could be 3, 4, 5. This could be 6, 2, 1, etc. Each of these little spots can be each of the 10 numbers from 0 to 9. So for the last 3 positions, it could be a letter of the alphabet. So it could be one of these 26 letters. Alright? So, this could be A, B, or C, etc. Alright, so that's what the last 3 are going to be. So if there's all those different combinations, then you just multiply these across. So 10 times 10 times 10 times 26 times 26 times 26. It's going to equal 17,576,000, and that's K. So when it's at 0, you can then minus 1 and within the function itself, and then have this kind of 3 just sitting outside. So it moves over 1, and then you can adjust the height by 3. So 1 unit to the right and 3 units up. That sounds right. So the answer to that should be A. When log of 5 of x equals -2, what is x? Alright. So how I remember this is log of A, B equals C. And this equals log of this equals ACB. AC equals B. So C in this case is -2. Alright, so 5 to the -2. It's 0.04. So that's K. Since 1 over 25 is 0.04, roughly. Alright. This is just a property of logarithms that you need to know. Alright. So let's move on. Which of the following lists those integer values of d for which the fraction 2d lies between 1/5 and 1/3? Alright, so 1/5 equals 0.2, and 1/3 is equal to 0.3 repeating. So let's draw a nice little number line. Let's put 0.2 and 0.3 repeating. So it's asking if, you know, like what numbers, you know, for d, for 2 over d lie in here. So let's check. 4 only. So let's see. Nope. Because if you put 4 there, then that's going to come out to be 1/2. So not 4, 3/4. So we already said that 4 is not a part of this. 8 only. 2 over 8. 2 over 8 is 1/4. And that equals 0.25. That's, so you know, 8 works. 7, 8, and 9. Here, let's move on to 16. 2 over 16 is equal to 1/8, which is equal to 0.125. So that's no. So 2 over 7, that's equal to roughly 1 over 3.5. So that's between 1/3 and 1/4. So that sounds good. So if 7/8 is good, that means 9 must be good. So yeah, the answer is D. For all real numbers a, b, and c such that a is greater than b and c is greater than 0, which of the following inequalities must be true? So, okay, if the best way to do this is just to label some numbers. So let's say a is 3, b is 2. So in this case, 3 is greater than 2. So a is greater than b for this case, okay? So, alright, so c is some number less than 0. So let's say c is -1. Alright, so okay, let's just try with these inequalities and see if they are good. So let's plug in our numbers. So let's see, 3 for the first one, 3 over c, which is -1 in our case, is greater than 2 over -1. So, alright, so this says must be true. Alright, so 3 over -1 is equal to -3, less than -2. So, we kind of got lucky for this one. This one came out to be true. Now for B, it says this is the opposite. And -3 is not greater than -2, so that does not hold. And you can just go through and do these for the rest of them and see that they don't hold. But we got lucky, so that will save you some time. So this triangle is shown below and has side lengths of 37, 38, and 39 inches. Which of the following expressions gives the measure of the largest angle of the triangle? Now, for every triangle with sides of length A, B, and C that are opposite, already, c squared equals a squared, b squared minus 2ab cosine of c. Alrighty, let's do this. Which of the following expressions gives the measure of the largest angle of the triangle? Well, so how you want to do this is that Well, first you want to label these. A, B, C. Does not matter which order. So, if you want to find the angle of, you know, ABC, or ACB, or BCA. This will equal, let's see, so the biggest angle will be, you know, if, you know, this, so you could draw this a little more. So, you know, this one is going to be the longest one. So this is going to be, you know, 38. And let's make this like the shortest one. Supposedly. Well, actually here, let's do another example. So let's say this is 10. This is 6, and this is here, actually. If you know the relations between triangles, then you know that, you know, this is true. So for the biggest angle, this is 90 degrees. So you know that when you have the two smaller legs of the biggest leg, you know, like the angle between these two, so this angle, in this case it's that. So in this case it's 37. That's not a right angle, but this is a right angle, but it's between these two. So let's just redraw this triangle to look like this. So if the angle between, you know, these two of the smallest legs, this is a 9. Then you will do this one. So this will be your, you know, 37 will be your A, 38 will be your B, 39 will be your C. Alright, so let's do this. Let's see if this is right. So the law of cosines says that, you know, 39 squared alright, so we want to solve for C. So let's get everything by itself. So A squared minus B squared plus 2A here, actually let's get this all over. So get everything to the other side. So get the cosine over. So 2AB cosine of C is equal to A squared plus B squared minus C squared. And now you do cosine of C equals A squared plus B squared minus C squared divided by 2AB. And then you take the inverse of both sides, so C equals cosine of inverse of A squared plus B squared minus C squared divided by 2AB. So your A squared is going to be 37, B squared is going to be 38, and it's going to be the minus 39 squared. So let's see which one. Well, all these three aren't fractions, so you can go ahead and, you know, cross out most of these. So yeah, if that's not supposed to have a minus sign. This is a tricky one. Because the minus sign inside, they just, yeah. This is stupidly worded. This is worded to trick you. Alright, so minus 30, so 39 is supposed to be minus. That's the only number supposed to be minus. So if you take this negative outside and distribute to these two, 37, 30, it's going to be positive. But 39 is going to be negative, so this must be B. So, alright, so he scores exactly X points on 4 equally weighted tests. So, if he scored X points on 4 equally weighted tests, then, the X amount of points he has times 4 equals, you know, the total weight, his total points. Alright. So, he wants to raise his average score by X plus 2. Alright. So, alright, so if this is the average that he wants after the 5th test, then we're going to do the same thing like we did for X. We're going to times this by 5. That's going to be 5X plus 10. So to figure out what we need from here, we minus this from his total average. So this is his new total average. So if we minus it from his old total average, we get X plus 10. So 10 is what he needs to make on his next test. So he needs to make, he needs to score 10 points higher. Alright. So cool. The intersection of lines L and M. Alright. And M. So this is going to be 180 degrees. So let's say that this is A, B, C, D. Alright. So let's do, you know, this one. So let's say, you know, this line, this intersection. Angle A plus angle B is equal to 180. Now if angle B is 3.5 times bigger than the measure of angle A, then angle A plus 3.5 angle A, since angle B is equal to 3.5 of angle A is equal to 180. So when you add these, this is 4.5 angle A equals 180. Divide through by 4.5, and angle A is equal to 180 divided by 4.5. That's going to be 40. So angle A is 40 degrees. Cool. A sequence is defined for all positive integers by the sum of n. Alright. Let's go to 2. Sum of n minus 1 plus n plus 1. Sum of 1 is equal to 3. What is sum of 4? Okay. Well, you can just plug in this right here. So, sum of 1 is equal to 2. Sum of 1 minus 1 plus 1 plus 1 is equal to sum of 1 equal to 2SO, or S0, plus 2. And if that's equal to 3, then sum of 1, or, alright, so we can find out what SO is. SO is equal to 3 minus 2, which is 1, and then divide by 2, so it's 1/2. Alrighty. Alright, so we're getting somewhere. So if we plug in for 4 here instead, then we get S of 4. So this is a repeating recursion relationship. So since we know S of 1 now, oh well, this was kind of useless. So if we know S of 1 equals 3, then we can find S of 2. This is going to become S of 1, and we know what that is, so that's 2 times 3 plus 2 plus 1. And that's going to be S of 2 equals 9. Now we know that. We can do this again, so let's find S of 3. It equals 2 times 9 plus 3 plus 1. So S of 4 is equal to S of 3, well, S of 3 is 2 times 9, 18, plus 3, 21, plus 1, 22, plus 2 times 22, plus 4, plus 1. And that's going to be 2 times 22, 44, plus 48. Oh, well, no, plus 4 is going to be 48, and then plus 1, 49. J. Cool. If a is an integer less than 1, which of the following orders the expressions absolute value of a minus a squared and minus 1a from least value to greatest value? Okay. Well, you could just, if a is an integer less than -1, well, let's just plug in -2 into all these. So absolute value of -2 is going to be 2. Negative. So then, alright, so negative a squared, when you plug -2 into that, you get 4, but you still have that negative, so that's going to become -4. And minus a, minus 1 over a is going to be 1/2. So this becomes -4. -4 is less than 1/2, which is less than 2. So that's absolute value is the greatest. This one will always be negative, and this one will always be positive. Alright, so this one is going to be over here first, and then it should be A. Alright, cool. Let's move on. No, wait, hold on. That was a mistake. My bad. I just said it over here. A squared is going to be the least. I don't know why I said that. Alright. So, at the school carnival, Anne is playing a game involving a stack of 10 index cards. Each card has a single number written on it. One card has a 1. One card has a 1. Two cards have a 2. So 1 is equal to 1, 2, 2. 3 cards have 3. Alright. And 4 cards have a 4. And alright, so if she chooses 1 card at random, she'll be rewarded a number of points equal to the number written on the card. Let the random variable x represent the number of points and receives on any one draw. What is the expected value of x? Alright. So this one's kind of easy. There's 10 cards. So there's 1 over 10. What is x? So there's 1 over 10 cards. But the total number of points is 4 times 4. It's going to be 16 points from this one, 9 points from this one, 4 points, 1 point. So this is going to be, 9 plus 16, 25, plus 4 plus 1. It's going to be 30 points. So this 30 points total so if the total number of points in the cards is 30 points and you only pick 1 card at random on average, you should get, 3 points. So 30 divided by 10. It's going to be 3 points. That's J. Alright. Sounds good. Which of the following is equivalent to the sum of any 3 consecutive odd numbers, x, y, and z, such that x is y and z? Sum of any consecutive odd numbers. Okay. So x is greater than y and z. With 3 consecutive odd integers. So let's say 1 plus 2 plus 3. Oh, that wasn't odd. Alright, so this is asking for 3 consecutive odd numbers, so 1 plus 3 plus 5. Alright, that's going to equal to 9. So if x is equal to 1, y is equal to 3, and z is equal to 5. If you sum up all this in 9, you come over here, you see, 3 times one of these numbers is going to give you the total. So in this case, y is 3, so 3 times y is 3 times 3, which is 9. And that's the sum that we got for these odd numbers. So B. Alright, so the mean of the set of 5 numbers, 42, 3, 11, 27, and x, is 24. Alright, so let's just go ahead and find the mean of this. So 42 plus 3 plus 11 plus 27 plus x divided by how many numbers there are. So 5 is equal to 24. So if we do 42 plus 3 plus 11 plus 27, that's 45. That's 83. Divided by 5 plus x, 24. So 5 times 24, that's 120. Is equal to 83 plus x. X is equal to 120 minus 83, so that's 37. Alright, so the median of this set, so let's write this in order the best we can. So 8, 29, 53, and y. We don't know if y is greater than 53 or not, but we'll see. So this goes to, so the median of this is 38. So, like the median, we picked the, so in an even set of data, we picked the two numbers that we think is in the middle, or that's in the middle, and we add them up and divide by 2. So if you do 29 plus 53 divided by 2, that gives you 29 plus 53, that's 82. Divide by 2, that's 41. That's not equal to 38. So that means that 53 can't be in the middle. So that means y must be grouped, less than 53. So then we would take y and 29 to be the two middle numbers. So 29 plus y divided by 2 is equal to 38. It's going to go to 29 plus y is equal to 2 times 38, 76. It's going to go to y equals 76 minus 29, that's 47. And it's asking for x minus y, so x is 37, y is 47. X minus y is 37 minus 47, that's negative 10. That's G. Cool. Alright, consider all rectangles such that the rectangle's length is greater than the rectangular's width. Alright, so the length is greater than width. And the length and width are whole numbers of inches. Which of the following parameters in inches is not possible for such a rectangle with an area of 144 square inches? Okay. So 48. So 48 is the rectangular area. Which of the following perimeters? Okay. So 144 square inches. So let's see. If it's 144, then that's 12 and 12. Alright, so that's the square of that. I mean the square root of that. So if you add all this up, that's 48. So that's not it, because that's correct. 60. So wait, maybe that's right. So consider all rectangles such as consider all rectangles such that the rectangle's length is greater than the rectangle's width and length. Alright, so length is greater than width. Alright. Which of the following perimeters in inches is not possible? Alright, so this is asking for a rectangle. 144. For it to be 48, that's only possible if it's 12 by 12 by 12 by 12. But this is a rectangle, so the length and width cannot be the same. So, yeah, I'm not sure what to say about this with an area of 144. So 144, that's 30. That's 36 times 4. So that can't be it. So this one, this is kind of, you can find the answer if you think of this as a square. So if this was 12 by 12, then that would be a square. But if this was a square, you know, the square root of 144 is 12. So if you had all this as 12, then this would be 48. But this is not a rectangle. So yeah, so this cannot be a rectangle's perimeter, since this will be a square's perimeter. So that one's kind of tricky. There's not really a good way to go about that, I think. Alright, so it gives us our equation for our circle. Okay, so that means our center of our circle is going to be 7 and then 8. And if it has a radius of 10, so radius of 10, let's say that's roughly 3. This is a meme in a STEM, but let's just say for this, for simplicity's sake, because it's really roughly 3. Alright, so if it has a diameter over here, which is you know, some x value 11. Alright, the x value is not important, but we could find it if we needed to. So if that was that much weight, then then the square root of the radius. Well, no, this is the actual radius. This is the radius squared, right? Because x squared plus y squared is equal to r squared. Alright, so this is, so roughly 3 is the r. So if we add 3 to the y, then we get 11. If we minus 3, if we take 8 minus the radius, then we get roughly 5. So 58 is J 5. Alright, cool. That wasn't so bad. You just have to know the equation of the circle. Alright. So the plans for a diving pole call for a rectangular prism that has a length of 30 meters, a width of 25 meters, and a depth of 5 meters. If the plans are changed to increase both the length and width of the pole by 10%, what will be the increase in the nearest 1% of volume of the pole? Alright. That has a length of 30 meters. 25 meters, and a depth of 5 meters. And a width. And the width of the pole. Alright, so if the plans are to increase both the length and width of the pole by 10% to the volume of the pole. So this is all these times together. So if we increase it by 33, Alright, so hold on. Let's do, so volume is equal to 30 meters times 25 meters times 5 meters. So this is some number, and this is the new one. So if we increase the length and width by 30, so this is gonna be, so by 10%. So 10% of 30 is 3. So we're gonna add 3 to these. So 10% of the width is 25. Is 2.5. So we add that to 25. So that's gonna be 27.5. And this is gonna stay 5 since this is just the depth, right? So the percent increase of this is gonna be, you could cancel this out. So how much percent increase? Let's see. 30. So 33 times 27.5. So 30 times 25. 907.5 divided by 750. So you take the new volume divided by V, and you take whatever this is, all multiplied together, divided by what this is. So you get roughly, 907.5 divided by 750, and you get 1.21. So whatever decimal you get, or however much you get after the 1, is how much bigger this pole's volume is than the original plans. So since it's 0.21, we look over here and we see 21%, and that's our answer. Alright, so well, you didn't see this, but yeah, it's been a few days, so let me do this real last one. So you can do this one by literally plugging in, if you ask Mr. Brown for the programs for your calculator, you can do this in literally like 10 seconds. But I'm gonna assume that you don't know how to solve this without a calculator. So let's just say that you had 2 minutes to solve this. So I'm gonna show you how to solve it. So we take this cubic polynomial, and we're gonna find the roots of it. So it tells us that it's -1. So if we can find the other roots, then we can deduce, which answer it is. If it has complex numbers in it, or only positive real numbers, etc. So okay, we're gonna do this thing called synthetic division. So we're gonna look at. So let me write this equation out. 4x cubed minus 2x squared plus x plus 7 equals 0. So you're going to find the roots, or the factors of 7. So you can get 7 from 1 times 7, or -1 times -7. So the factors are going to be 1, 7, -1, and -7. So the fastest way to do this is, always try -1, because -1 almost always will be the one that will give you it. And if it doesn't, then try the other ones. So, all right. So let's write -1 out here, and then write this kind of box. And now we're going to take the coefficients, so the numbers in front of them, in front of the polynomials. So for 4x cubed, we're going to write 4. -2x squared, write -2. For x, write 1. For 7, write 7. So for this process, you'll learn about this in algebra too with Mr. Brown, but I'm going to go ahead and show you how to do it. So once you have the coefficients, the numbers in front of the the x's, and then the number right here. You just bring that down. So you're going to take this first number and you're going to bring it down like that. And now you're going to multiply this by the thing that you're factoring by. So you're going to do 4 times negative 1 minus 4, like that. Let me make this bigger. I'll do minus 4, and then you're add these two. Negative 2 plus minus 4 is negative 6. Then you're going to do it again. Negative 6 times negative 1 is 6. 1 plus 6 is 7. Then you're going to do 7 times negative 1, which is negative 7. Then you're going to add 7 plus negative 7, which is 0. So you know that that you have a root if you get 0 for the very last column. Alright? So now that you know this, you take this and you write x plus 1. Because if you put negative 1 right there, then you'll get 0. And that means negative 1 is a root. So this is going to be one of the binomials that's going to be factored out. So these coefficients now are, you can tack back on the x's, the x squared and the x, and etc. So you're going to take this one, and it's going to be 4x squared, then minus 6x, and then plus 7. Alright, so that's factored out pretty nicely. So let's find the other factors. So let's let they equal 0. So now that we know this, we can divide both sides by it, and anything divided by, and 0 divided by anything other than 0 is going to be 0. So that's what we got. Let's divide everything by 4. Both sides by 4. X squared minus 6x divided by 4 plus 7 divided by 4 equals 0. Let me bring this over here. So let's minus 7/4 from both sides. Alright, let's reduce this, simplify this to 3 over 2, x equal -7/4. Alright, let's complete the square. Hold on. So when you complete the square, you take you take 3/2 and you multiply it by 1/2, and then you square it. Alright? But you're also so you basically just added that. So you have to add it to both sides. Alright, so x squared minus 3/2 x, that's going to give you 9/16, and combining fractions, you times that by 4, times that by 4, that's going to give you -28 divided by 16, but if that gives you 9/16, then 9 plus negative 28 is going to give you negative 19 over 16. That's what equals. So now we can turn this into a perfect square. Equals negative 19 over 16. And now we're going to take the square root of both sides. And a square root of a negative number is going to give you I. So let me do x minus 3/4 because the square root of the squared goes away, equal to square root of 19. Square root of 16 is 4. And the square root of a negative number is going to give you I. So that's going to be plus or minus. So when you add 3/4 to both sides, it's going to be x equals 3/4 plus or minus square root of 19 over 4i. So that means the two roots are complex because it has this imaginary number. So anything that has a square root of a negative number is complex. That's something you'll learn about in algebra too. But this means x equals 3/4 plus square root of 19 divided by 4i, or x equals 3/4 minus square root of 19 over 4i. So that means, which of the following describes the other two solutions? So we know that that's -1, so the other two solutions are these. And down here, both are complex that are not real. Yep. These are both complex since this has I. So, okay. Alright. Now, like I said, you could do this in your calculator in 10 seconds, but yeah, this is pretty much how you would do it without a calculator.